To review periodicity, I want to go across a period and say a few trends that are happening. Pick and choose one period. For example, period 3 is good. IB usually challenges you on that. Now, the first thing you should realize is only one thing decreases as you go across and three other properties go up. Atomic radius decreases. This is one thing that you really need to pay attention. For example, period 3 has 3 shells of electrons, but as you go across, number of protons or nuclear charge goes up. Therefore, the size sort of gets smaller because now there is a stronger magnetic pull for those electrons. As you go across, ionization energy increases. It will be more difficult to remove the electron. Also, as you go across and you get closer to nonmetals, electronegativity increases. The ability of an element to attract the electrons to it, shared electrons. Now what happens as you go down a group, any group, whether it's group 1 or group 17, which are usually the groups we compare them to each other. As you go down this group, atomic radius increases because you simply have more shells. So if you come here, period 3, you compare to period 4 has one extra shell, therefore further away. Also, shielding increases, meaning period 3 has 2 shells of inner electrons that is protecting the valence electron. Period 4, like potassium, has 3 shells of electron that is protecting the valence electron. As you go down, also ionization energy is going to decrease. You need less energy to remove the electron, therefore it makes metals more reactive. Also, as you go down, electronegativity goes down. Remember, cesium is has the smallest value of electronegativity. So pay attention to this. Now let's just apply and stretch your information, at least in regard to size or atomic radii. Many times IB will challenge you and say, put them in order. For example, this case, increasing size. That's radii or ionic or atomic. What you should do is do number of electrons, and I'm not going to do 1s, 2s. I'm going to do it the old-fashioned simple version. This is 2, 8, 8. 2 minus for sulfur means you have gained 2 electrons. And if you put number of electrons, sulfur is 16, that's its atomic number, so 16 protons. If you look at chloride, it's also 2, 8, 8. These two are isoelectronic, and in this case, this has 17 protons. And finally, if you look at phosphide, it has also gained 3 electrons to look like argon, so all 3 are isoelectronic, and it has 15 protons. Now, the one which has the largest number of protons, has the largest nuclear charge, is actually the smallest of all. So since they all have 18 electrons, chloride is the smallest of all, then it's sulfur, and the largest is phosphide because it only has 15 protons. So in order of increasing, I'm going to put chloride is smaller than sulfide, which is smaller than phosphide. Now let's look at another treatment. This time you have cations, ions of the metal. If we look at sodium 1+, that's 2, 8. It looks like neon, and it has 11 protons. If you look at aluminum, likes to lose 3 electrons to look like neon, 2, 8, and it has 13 protons. Finally, magnesium is 2, 8, 12 protons. So in this case, then again, the smallest of all is this because it has more protons compared to number of electrons that you see, shells of electrons. So aluminum 3+ is the smallest, then goes magnesium, and finally goes sodium 1+ being the largest. Now let's look at atoms. For example, argon is a noble gas, 2, 8, 8, and it has 18 protons. If you look at potassium, 19, atomic number 19 is 2, 8, 8, 1, 4 shells, 19 protons. And finally, if you look at chlorine, is 2, 8, 7, and it has 17 protons. Now this time I cannot look at number of protons and make a judgment because they have different shells. First thing first, the largest of all is actually, in this case, is potassium because it simply has 4 shells. Next thing I'm going to do is compare argon to chlorine, and I'm going to say argon is the smallest because they have 3 shells of electron each, but argon has 18 protons. So this is the smallest of all. Therefore, argon smaller than chlorine, and the largest of all is potassium. Now, the last thing I want to do in this series as a review is similarities between group 1 and group 17. Group 1 are alkali metals, and we're not going to include hydrogen in it, just lithium, sodium, potassium, rubidium, cesium. Group 17 are halogens. Now, they have 2 similarities. They have a couple of similarities. First of all, as you go down, so this is common between the two, is as you go down, so let's just write it, as you go down a group. The first thing is atomic radius for both increases. So the size or atomic radii increases. The other thing that is true in both cases, whether you are alkali metal or a halogen nonmetal, is your ionization energy decreases as you go down. And finally, electronegativity has the same sort of correlation. Electronegativity decreases as you go down. Now, there are 2 differences. So differences, let's just write it in red. The first, let's just, as we go down, let's just look at metals. As you go down, this is what happens. The metals become more reactive because their ionization energy is low. So the first is metals become more reactive compared to each other, more reactive. In that case, cesium is the most reactive, then rubidium, and which is more reactive than potassium, and potassium more reactive than sodium, sodium more than lithium. And the other thing for metals is as you go down, their melting point decreases. So as you go down, melting point decreases. Why? Because metallic bonding is getting weaker. Okay, now let's just look at, so the common are in green. I'm not going to worry about that, but let's just look at halogens as we go down. There are differences between group 17 and group 1. Is the first is as you go down, instead of reactivity increase, you become less reactive. Halogens become less reactive. Why is that? Because they become less electronegative and they cannot hold on or attract the electron as before. So in this case, fluorine, the top of the line, is the most reactive. Then chlorine, more reactive than bromine, more reactive than iodine. The second main difference is as you go down, remember this is a gas, this becomes a liquid, this is a solid. Their melting point rather increases. So melting point increases, and that is due to London dispersion. So this is because of London dispersion, which is due to more electrons that you have, more electrons by the nonpolar diatomic elements. So pay attention to physical properties, be able to compare group 1 to group 17, and as you go across a period, then you should be successful answering many of the questions.